Okay, good night everyone. Welcome back to Dan Does Data, looking at For Well Thou Knowest. Tonight we are continuing to look at our Shakespearean font data. And last week, you might recall, we tried to rebuild the data set because I felt like it was cheating the way it was. And I eventually settled on something where I stuck the words sort of in the middle of whatever the phrase was, and I took a longer phrase and I shortened how much data I was taking to begin with, and all this silliness. Well, I realized I built some stupid models out of that just to say, oh, is that going to be cheating just as much? And it is. I wasn't fiddling with the height at all. And so I realized the better thing to do is for any given phrase that I've got to randomly jitter it around left, right, up, and down. So this is my var data, which you might recall I had last time. And all I did was add a couple randomly generated numbers here. I say, well, how much do I do in the x? -3 to 3, because I've got jspan as 3 up here. And similarly in the y. And then when I go to create the data, I do that here. And so that's what I just did. That's why tonight we were a little late getting started. So I hope you'll forgive me. But now we've got new data, and if it's also cheating, well, maybe this problem isn't as hard as I thought. So that's what we're going to learn in the probably next few seconds here. So let's read in the data as normal. None of that's changed. Let's plot. Now let's take a look at that, just so you can see this data set. Yeah, here we go. So this should look a little different. Things are all blitzed around. This is really low, that's really high. Left and right doesn't really matter so much anymore, I guess, since I'm cutting in anywhere. But this should break those obvious symmetries using just the height to determine where things go. So that's good. I'm a fan of that. All right. Let's make everything else is the same as before. We're going to make our testing and validation data set because we're trying to predict something. I apologize for noise as my air conditioner comes on. I apologize for noise from phones. Don't worry about it. All right, we did that. Let's read in our data as normal. Let's assign our data to our testing and validation, training and testing sets. And then let's grab some keras. We like that. User GPU. Okay. And I've got a dead stupid model here. I want a stupider model though. Yeah, I want an even stupider model. I want a model with one node, which is to say, I want to do logistic regression, essentially. So let's have at that. Yes, this is all the same. Simple model, categorical cross entropy, because we got 5 classes. If you got 2 classes, make sure you use binary cross entropy. Tangent array was passed for output of shape. All right. Loss expects target to have the same shape as the output. What changed here? Train labs. That's normal. Test labs. 233, whatever. N rows times n call. No. Times n calls. 1024. N rows. And calls. No, that's right. Yeah. So train flats. What's the problem then? Target array was shaped this, was passed for an output of shape none, 1. This is unusual. This loss expects targets have the same shape as the input. Oh, right. There's not 1, there's 5. There's 5 outputs, quote unquote, because I'm computing 5 scores, 1 for each class. So it's in fact yelling at me for a very good reason. Okay, batch size, I'm going to change that to 32 for whatever reason. I don't think 128 is appropriate. Let's see what happens. Accuracy, 20%. which is 20% is about what I expect if it's unable to do anything. But this is logistic regression had the same problem before, so I will not be surprised by such a thing. I won't be building as simple a model as possible anymore. So let me just, I don't even need this other stuff. I can grab it later if I need. Alright, so that's no longer going anywhere. Yeah. No, it is slightly changing. Okay, let me just interrupt that, actually. And I want to grab my sklearn. There we go. Let's do the same thing with sklearn. Or scikit-learn if you're familiar with it. Just because I want to see if it gives me the same results. Where's my train? What's my other stuff? Train flat. Numpy.argmax, train labs, yes. Test flat, yeah, there we go. See how long? That shouldn't take very long. It doesn't give me a progress bar. One serious problem with skflow. No progress bar. This is, oh, that's right, it uses tons of memory. I might have to kill it before it overwhelms my machine. Using 26 gigs of virtual memory, apparently. News to me. It's taking too long, I'm getting impatient. Alright, I'm impatient. In a normal world, I might be willing to put up with that. But live streaming, I don't want people to sit around watching my processes choke up all their memory. And that might just be choking, so we might just have to kill that entirely. Goodbye. That's fine. No big deal. We can just read in the data again. Shoo. Close call. Auto indent again. Turn that off because I'm pasting. There we go. Oh, you're killing me. It's trying to send. Slimux is trying to send to something that doesn't exist anymore. A pane that doesn't exist on the left. 1 second here while I set some colors. Not light, but dark. There we go. There we go, much better. Let's quick recovery. Read in some data. Just look at that again, just so we're... Yes, it's all the same. Nost. Oh, we even get the apostrophe here. That'll be fun. See how that gets handled in different fonts. Take a little bit of time to split up the data. 10 seconds, which is forever in the streaming world, right? If I'm taking 10 seconds to read in my data, that's way too long. Alright. Let me just build a stupid neural net then. Let's just do that, shall we? Okay. Shouldn't take too long. Accuracy 35, that's getting to be high. That's getting to be high, 45, 46. Okay, but it's not 100%. It's not perfect. So, I'm not sure. Yeah, I guess this isn't surprising that it could get somewhere. 57, are we going to cap out around 57? I mean, I could train for way more epics, of course, too. 60? This is actually climbing. I'm surprised. Alright, tell you what. Let me do something that's even smaller. But this isn't climbing instantly to 100%, so that's a plus. Really? This still takes this long to train. That surprises me. Because I cut the number of initial parameters, you know, by a factor of 4. So I was hoping for a better speed up. So this might just have to train for a long, long time. Validation loss, validation accuracy, about 34%, 32%. This actually isn't that bad. And it's climbing. But it's not perfect. And it's not 100% anymore. And that was the goal, to keep myself from cheating. And some, you know, there might be some features it can determine. If we look back at that image, which I've sadly closed. Alright, I don't actually care what that model is going to get at. So that's... Let's go back and take a look at one of the images. Right, so there are things that could be picked up on, I guess. Just large blobs might be indicative of this. Blobs of various sizes might be indicative of this. So I'm curious how a convolutional model will do. But recall, like, what I really want to do... I should just leave this open and not kill it. What I really want to do is look at small slices, say 8 pixels wide or something, or 10 pixels wide. Look at that, generate something, move over that many more pixels, use that to update this information, generate that. Because if you're leading one certain character into another, gosh, this one isn't even readable. That will have certain other properties. So there's sort of a recurrence. So I wonder if it's like some kind of RNN. But first, let's do the convolutional network and see how that does. That might do pretty well. Might do terrible. Oh, no. Of course not. No, that's not what I want to do. I want to look at the model dot. I want to look at the weights first. That's obviously what I want to do. I thought I had number of parameters as an option. Name, non-trainable. I must be thinking of like skflow or something. Something like that. 1024 times... the number of parameters is definitely going to be 1024 times 4 plus 4. There we go. There we go. Let's look at those first 4. Interesting. So I've got 2 kind of random guys. And 2 guys that are... Is there something in the middle or not? Right? That's weird. And these are just like slightly offset from each other. That's interesting. Well, I guess the one, if it's a small font, it's going to tend to leave a bigger gap in the bottom, even if it's jittered around. If it's generally offset up, then you can get some information from that. It's like, oh, well, it tends to be centered in this region. This other font tends to be centered in this region. So yeah, that makes sense. I still don't know why it refuses to climb, given the just one. Sorry, given just plain old logistic regression. That is frustrating. That's a problem I feel like I've had before. But it might be something weird to do with the data or something. What is our confusion matrix? Let's have a look-see at that. Come on. Yeah, it's so we see class 2 here isn't really getting predicted at all, and class 5 is also pretty rare. Right? Am I reading that correctly? I'm pretty sure. Each one of these rows should sum to the same thing. Yes. So that's the actual class, the row. And the column, of course, is the predicted class. So yeah, class 1 or class 0 and class 4 are dominating. Or is it just everything gets confused with class 4? Or class 3? Class 3. This is class 3. This one? Everything gets confused with this? That's interesting. All right, I suspect a convolutional model will help. I don't want to do the scikit-learn style, unfortunately. That didn't want to work, so we're not gonna do that anymore. Let me just grab this stuff. Convolutional. There we go. Right, and I no longer have train flat. Oh, is train flat the only kind of training I have? Oh boy, what did I do here? What did I do? Oh, I have data. There we go. Let me grab my data. Train data? Yeah, there we go. This is data of the appropriate indices. That should be fine. Right? Because it's data flat, and data flat is just whatever the reshaping is. Yeah, so that'll be fine. And let's change flat to data here. Perfect. And just so we remind ourselves, let's run those. Even though I'll run them again later. Train data.shape. 16 by 64. Oh, not where I want to be. In rows and columns. And no longer dense. Conv 2D, is that how this works? I always forget the obvious syntax. Have to look that up, thankfully. I have the Keras documentation open because I knew this was going to happen. Convolution 2D. Right. And it's how many kernels I have, what my convolution window size is. That's 1D. Let me look at 2D. There we go. Convolution 2D. Right. Number of filters. Sort of how many neurons, quote unquote, you want in that layer. What are our size in the, our window size in the X is, window size in the Y, what the border mode is, and what our input shape is. Convolution 2D. Yeah, let's still do 4 kernels, because why not? Some people like 3 by 3. I got a lot of things I need to get through. You know, so I'm gonna do 7 by 7 or something. That's the same shape, by the way, so I'm gonna do smaller. 3 by 3. Border mode equals same. And I think this should work. This might yell at me. Let's see. Convolution 2D is not defined. Because it's capitalized? Because it's capitalized. Also, I might not have imported it. Input 0 is incompatible with layer convolution 2D. Expect endem 4, found endem 3. Right. Right. Because you have to have whatever the right number of channels is. And reshape. And it's expecting, okay. -1, comma 1, comma in rows, comma in calls. Right, because you got to have the number of channels in there as well, not just in a simple 2D image, or a simple 2D array rather. So this is going to be 1 comma. There we go. They have the comma on the end? They don't. Alright, I'll take mine out. I'm missing a... one too many, one too few parens, apparently. Oh, I need 2. Shouldn't be that hard. Just add in a line, buddy. Yeah, there we go. Activation, we'll say rel u. And model.add flatten. Which I should have. Yeah, there we go. I've already imported that because I stole this code from another project I did. Okay, let me just add the rest of this stuff then. We want a max pooling there, right? Yes, we do. We do. How did I do this last time? Max pooling 2D. It's like I should find my old Keras code, right? Proj/Keras/Keras RNN, Keras tutorial. There we go. What did I do over here? Really? Did I not? I didn't use it at all? Ugh. You're killing me. Oh, no, wrong place. What? Oh, yeah. Okay. Jeez, oh man. Fool. There we go. Right, so I activate. Oh, right, because this is where I did my funky activations. Let me just steal this line. And yeah, let's add some dropout while we're in the neighborhood. This is my final one, so yes, that makes sense. Okay. Let's drop out half of them, just for giggles. And let me just take these. Let me copy that. Let's do two convolutional layers. I don't think I need to declare my input shape the second time. Let's find out. It should be able to infer it. That would be really good if I could do that. Save me some headache. Let's make this one 8. Activation rel U, drop out this time at the end. Yeah, sure. I don't remember where I had already redone the whole model. Let's just do this. Takes a little time to end the dropout. Compile that. Okay. Reshape our data, and then I'm prepared to have it yell at me about the data shape. We'll see if I did this correctly. Did I push the Reddit button? I did. Right, so this week, if you see me on Reddit, feel free to upvote. In previous weeks, I've suggested downvoting. So we're trying something different this time. It's got to read in all that data. It takes a little while. Probably choking my machine. Now we're okay. We're only 20% memory. I'm surprised this is taking this long to sort of... Oh, right, because it's got to compile it the first time. I don't like when you do model.compile, it doesn't actually compile anything. It just, yeah, I'm totally going to compile that. That the Keras used to work that way. They updated it, now it doesn't compile until the first time it tries to fit. Which, if you're going to fit anyway, it doesn't matter, but it makes me think I've done something wrong in my fitting, in prepping my data, rather than in my model construction. Okay, so I probably don't need that. We'll keep that open in case I need it. Right, get status. I need to add more things in my git add. We'll just do some of this. var data and var data in. We'll say add jitter to dataset. And model. There it goes. Ugh, that took way too long. Alright, so each epoch here is going to be 120 seconds because I've added a ton of stuff to do with this data set. Right, because the one image is 1024 position, 16 by 64, so I have to do 1024 times 3 by 3, so that's like 1024 times 9, call it 10,000 things, computations I gotta make, and I gotta do that 4 times, that's 4,000 computations, just for this first stupid convolution. 10,000 things going to ReLU. Then I gotta do this 2 by 2 max pooling, what a headache. Then more of this, more of that, more of that, more of that, more of that, more of that. Okay. See if this gets anywhere. This looks like it's not doing too well. But granted, it's in the first epoch. Jeez. hovering right around random, right there. I would think this would be able to do something. But it's still fully random. 6, 5, 4. Let's split my data 50-50. Well, let's see. Let me save off those weights and such. See what we end up with. It might just be take a while, a little bit of time to eventually get up there. That is an entirely reasonable thing. The amount of data I'm toying with here is a little more than I should be, perhaps. I probably should have done a single word worth of data rather than this big mess. Oh yeah. So that's our simple data set there. The convolutional model doing pretty terrible currently. I think I'm going to let it get through. Wait. What is this? Oh, no, this is epic number 2 of 4, right? Not that it's on. Yeah. 4 total epics that I said. I don't think it's going to get anywhere, though. But if I say h dot. Oh, really? It didn't save off because of that? Really? Is it in model? Oh, model dot get weights. Yeah. There we go. Say 0. So these are our 4 convolutional kernels that it's come up with. This one is finding something over here and in the middle. This one, like, I'm visualizing by looking at the digits, which, again, if you don't have matplotlib, it's something you can do. That can be very nice. This one is finding something down in this corner. This one is finding not a whole lot. A little bit here and a lot of negativity. Oh, so it's like a Q, part of a Q coming down. You can think of it. It's probably not. I mean, this is basically a random model. So that's just silly at this stage. Why don't I... Let's take out this business. Take that out. Just save ourselves a little bit of headache. Let's try this again. Let's see if that's any faster. Okay, so that's like 60 seconds to an epic, and still pretty terrible, which is misery. But that's fine. That's fine. You can go away. I want to play with something here. What if I make this like 7? Yeah, 16 tall. That's like half the space. Like 5. Is this going to add a lot of time to my computation? Shit. Something didn't work. Wasn't happy about that. It's good. Alright, everything seems fine. I don't know what I was yelling about before. Alright, so that added a little bit of time. From 68 to like 75 seconds. Here's what I want to do, though. Let's do that. And we'll add another activation. Well, this one will be sigma. And I don't know, 32? Is that too many? We'll find out. Max pooling, should be using valid padding. Is that the default? Border mode valid? Yes. That is the default, so that's good. Let's see if that's way too much. Question from the audience, what IDE is this? This is just IPython. And by IPython on the left here, IPython on the left and Vim on the right. And if you're wondering how am I getting things from the right to the left, this whole session is in what's called tmux. So I have a guide on how you can set up your tmux environment this way. Oh, there we go. See, now we're getting to like 30%. We're getting somewhere. So Slimux is what allows you to connect Vim to an arbitrary tmux pane. Let me grab the link while we're waiting for this to train. I actually have, I'm working on an ebook, among other side projects, that I will be probably announcing in the next couple weeks or so. So yes, it's just IPython plus Vim plus tmux plus Slimux equals win. All right, now we're getting somewhere. This accuracy is actually climbing pretty quick. This is in one epoch still? Okay. I suspect this kind of model is still not going to be perfect. It's still going to get confused by a lot of things, just depending what shows up in the image. But this is doing a decent bit here. And so what did I just change? I have one convolutional layer with a pooling layer, and then I just added a neural net in between it, or not, I didn't add a neural net, I added a densely connected layer between it and the final logistic regression output. But it's good to see that it's getting some decent accuracy in one epoch, and it doesn't take forever. Granted, it has a bajillion parameters. Wow, that jumped. Accuracy here, 56. Validation accuracy, 80%. That's unexpected. How did I split? I split it randomly, right? That's really weird. I guess I could have gotten that lucky with the split, yeah. Train index, test index. And generating this in a sane way, wow, that's weird. That's very strange, very, very strange. And I had checked those, that the set was different. I definitely did not expect the validation accuracy to top 80% in one epoch even. That is very surprising. And now our training accuracy is getting that high. That's super weird. I guess our training accuracy might just have, this is more than a handful of errors. Alright, so that's going to finish very soon. I don't even want 4 epochs on this anymore. I want like 2. I suspect if I let this train for a while, it'd probably get up to at least 85, maybe 90, who knows. Which is pretty good. That is surprisingly not bad. Let me steal the code for creating the confusion matrix. Yeah, there we go. Doink. Now that I got that, I want this to make sure it stores off the weights, and then I'll kill it as soon as it starts training the next. There we go. 90%. Look at this. Why is I guess the validation set happens to be much easier than the training set? That's so strange. I split them 50-50. Scout's honor on that one. Train index, test index, right? If I say set train index dot intersection set test index, nothing. I'm not using any of the same positions. That's so weird. That's just really, really, really strange. Oh, not test flat. Ho, not this time, buddy. Test data. So you're going to see this. This confusion matrix is going to look very good. So maybe this convolutional thing is all you needed to do. And so why is the convolutional thing working? Because portions of the font can occur anywhere in the image, really, right? Certain letters it's not even certain letters, it's just all the letters, or many of the letters for a given font have common characteristics that by eye you can pick out, like, oh yes, it's got serifs, or it doesn't have serifs. That kind of stupid thing. The convolution is starting to pick that out. With one convolutional layer, I was not expecting to pick this much out. And I guess I also have a fairly dense layer here. I could have cut down this number, surely. See, look at this? Yeah. And if I say plot dot p-color of conf. You're going to see, oh geez, what did I do? Yeah, let me kill that real quick. That's, oh, no, not p-color. Dot mat show, right. Because otherwise when you plot, it like inverts, see, 0, 0. It's all good, we're all good here, we're all good. But yeah, it's like right on for this. You've got about 45,000 of each, I think. Yeah. Right on in class 0. Pretty close in class 1. I'm looking at the number down in the lower left here. Not too bad. And, you know, these last 3 classes tend to get confused a little bit. And that's why you can see some of these off diagonals are bigger, like this one. Things that are actually class 2 tend to get confused for class 3 more than anything else. And again, if you don't have matplotlib, you can just look at the conf, the confusion matrix and the array values. That's usually not too bad. If you've got 100 classes, that might get to be challenging. That would be tough. Yeah, so here's the same. Class 2 looks kind of like class 3. Class 3 looks kind of like class 2. Class 4 looks kind of like a lot of things. So that's interesting. So let's pull out some of our weights for this guy. I don't know why I grabbed that particular. W1, B1, what do I got here? I got this guy, I got this guy, I got this guy. That should be good. Bingo. Okay, so I want to look at, these are our convolutional kernels. So let's make sure we plot those in a cool subplot, right? There we go. But I'm not plotting data, and we're not doing 5 of these. There's 4. 4 there. W1, no, not W1, yeah, W1. Have I? think that's all we gotta do. Let's have a look-see. Too many values not back. Expected to. W1. 0. Oh, I see. 0.shape. This shape of these things is really weird. Yeah, because it's expecting multiple channels. So of that, but the first row, that thing, first channel, because there's only one channel in all of those. Right? One too many parentheses. There we go. There we go, much better. And let's do this one as gray. CMap equals plot.cm.gray r. Gray reversed, that stands for. There we go. It's a little bit, you know what, let's do hot. I thought I liked gray. I don't really like gray that much. Oh geez, that's not what I wanted. Hot. So hot's just going to use red to brown, basically, to plot our colors. There we go. I wonder if I can just do a matrix show instead of a p-color mesh. Can I do that? We're going to find out if I can do that. Nope. Learn that one. Can't do that. Okay, so p-color mesh it is. So these are our 5x5 initial kernels, the initial features that we're finding. And so you can sort of see interesting things. Just so we don't forget. What if I say numpy.array w1 but d-type equals numpy.float16? Because I do not need this much precision here. All right, well, whatever. Right, so these white values, and these values are all like flipped. Right, things over here become things. Is that the yellow then? Right there? This is a pretty neutral tone. Oh yeah, 1.19. Yeah, okay. So the white is the hottest, the biggest number, and this black here is like the smallest number. Let me make this a little bit bigger for you. So what's going on here? This one is detecting a couple hot things here, followed by a space, followed by something hot. The red is kind of average, a little, you know, and then there's nothing over here. This one is like a center dot surrounded by nothing on the upper and lower left corner, I guess. The yellow is more or less is mostly positive. So again, this didn't drain for a long time, and these are just 4 kernels of things it's initially finding. So that's kind of interesting. That's what our simple convolutional model is doing. Also, cool Tmux trick, you can zoom on a particular pane. Super useful. I highly recommend it. Alright, so I said I got a little late start, and I thought about going for the same amount of time, 1 hour, but I think we're at a reasonable place now. The convolutional model is, of course, very good, which is not super surprising given that it's got a lot of data to work with. But next, I want to build a recurrent neural net model where I look at a few, like 8 pixels at a time or something, in order to build up that image, build up the idea about what's going on. So you look at, say, 8 pixels, compute some result, you move over 8 pixels, use your previous result and this to compute something new, and so on and so on and so on. Because some letters bleed into others depending on the font. Some fonts have an apostrophe and some don't, I guess? Maybe it doesn't have an apostrophe, or it might be off the map. Well, this one's set pretty low. I would have thought it would have shown up. Question from the audience, is this a regular CNN? Yeah, this is a regular convolutional neural net. There's only one convolutional layer, just because it's we're testing, basically. So that's this. Convolution in a pooling layer with some dropout training, and then just a dense layer of 32 nodes, followed by our final softmax, or logistic regression, however you want to think about it, your categorical classifier. So I think that's where we're going to stop tonight, just because that's a good stopping point. And again, if you have any questions or anything else, hit the chat. Definitely leave a comment. I check all the comments. Send me an email. Leave me a comment on Reddit. Tweet at me. Whatever you want to do. I think that's all we're going to do for tonight. So again, stay safe in the data mines.